My name is Aiman Shafie. My metric number is BE40603. So we are from Group 12. Today we are going to present about the title of the power quality assignment, which is the generation of different power quality disturbance and their respective mitigation. So without further ado, I will continue for the introduction part. So for the introduction part, the power quality can be defined as a form of reliability between supply and load. So when there is reliability, there will also a disturbance. So there are several disturbance that could affect the operation of the system, which is for the first one is voltage sag, voltage swell, voltage flicker, harmonic, and also transient. So the causes for this disturbance can be seen in the table, which is remote system failure for the voltage sag and swell. For the voltage flicker, the causes is the motor starting, arc furnace. The harmonic can be from the system resonant and also nonlinear load, and for the transient, it can be from the lightning and electrostatic discharge. For the effect, when the disturbance happen, malfunction of PLC, the failure occur in the hardware, fluctuation of voltage, reducing power system performance, and also instability in the system are the effect that could affect the system when this disturbance occur. So some of the solution can be seen in the to solve this problem, which is for the voltage sag is the uninterruptible power supply. For the swell, which is the resonant transformer. For flicker, which is we use static VR system. The harmonic is to eliminate the harmonic, we can use active and passive filter. And for the transient, we use the surge arrestor. So for this assignment, there will be two tasks to be simulated. So for the first one is mitigating PQ problem caused by overvoltage transient. The second one is harmonic producing load and mitigating filter. So the next part is the methodology, which is the overview of workflow that will be done in this assignment, that has been done in this assignment. So for the first one, we must do the literature review, which is find the information about the disturbance, and then we need to draw the circuit in the MATLAB simulation, which is for the task 1 and task 2. And we run the simulation. After we run, if there is no error detected in the simulation, we can observe the output result. But if there are any error detected, we must look back at the connection in the simulation or the parameter in the simulation. And then after that, after we obtain the result, we just need to analyze the result. I think that's all for my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akif bin Azim, and my metric number is DE100184, and I'm from Group 12, and I'll be presenting Task 1 simulation. Here we have a equivalent transmission system, and the length of the transmission line is 200 kilometers, and between the line we connected a capacitor in series, and at the end of the line we connected a shunt inductor. Our fault is applied at the loading terminal, and we will monitor the surge protector device voltage and current via scope 1 and scope 2. So let's move on with our result analysis. So right here we have the graphical result from scope 1. The graph above here provides us the voltage graph against time for our capacitor, and the graph below here is our current graph at our metal oxide varistor. This graph is current against time. So from this graph we can see that when the fault applied at the second cycle, the voltage at the capacitor peak, and we can see that our surge protector device current is conducted, and the current value that was conducted was 8.4 kilo amp. You can see that our metal oxide varistor is protecting our capacitor. So let's move on with our second result. So here is our voltage against time for our metal oxide varistor that is connected with our shunt inductor, and the graph below here is our current against time for our metal oxide varistor for the shunt inductor. So when the fault applied, we can see an impulse graph which at peak is at 803.7 M. So we can see that the current is conducted by the surge protector device to protect our inductor from over voltages. So that is all for task 1. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Azim bin Muhamad Fauzi and my matric card number is DE190145. So today I will explain for task 2, which is the simulation of harmonic producing load and mitigating filters. So here is the MATLAB software. So here is the 3-phase harmonic filters that we have constructed in the MATLAB Simulink. So this system, it consists of a few main components here, which is a 3-phase generator, the power transformer, rectifier, a DC side generator, the pulse generator, and also a 3-phase harmonic filters, which consists of the C-type high filters, double tune, and also the high pass filters that connected in parallel with the capacitor bank, and these filters are connected to the circuit breaker. So therefore in this simulation there will be two conditions, which is with and without filters. So we will monitor the output waveform of the voltage and current, whether the filters will filter the harmonic distortion in the system. So now we can run the simulation for the first condition, which is without the 3-phase harmonic filters. So what we have to do, we just have to open this circuit breaker, which means that these filters are not connected, and then we run this simulation with the firing angle of 90 degrees. We can get the output of voltage equal to 442.02 kilovolt with the current of 1.77 kiloamp. And we can monitor the output waveform of the voltage and current in this power system at this scope 1 here. As we can see here, at voltage and current at B1 has a distortion. So we can see how without filters affecting the output waveform. So we can try run the simulation with the filters connected. So we have to close the circuit breaker, which means that these filters are connected to the power system, and then we run the simulation. And we can see that it improved the output voltage, which is equal to 499.22, which is approximately to 500, and then 2 kiloamp of current. So at the scope here we can see the output waveform. The voltage and current here, it almost eliminate all the harmonics in this power system. So these are the use of the 3-phase harmonic filters in the power system. So for the FFT analysis, we can see that with and without filters, it eliminates the total harmonic distortion, which improved from 13.86% to 11.52% of THD. Therefore, by using these 3-phase harmonic filters, it helps to remove the harmonics that occurs in this 3-phase power system. Okay, next for the last one is to generate the output graph of the impedance versus frequency of this power system. So this is for the open breaker circuit, which is it is without the harmonics filters. So what we have to do, we have to click on the power GUI and then find the tools known as the impedance measurement, and it will construct the graph. As you can see here, this is the impedance versus frequency graph, and then when we pin at the frequency of 60 Hz, we can get the value of impedance at approximately 417, which is equal to 416.667. And then when we can see at the theoretical value, we can see it is identical, which is at 60 Hz, it is equal to 417. Therefore, we can find the total reactive powers of this power system when we apply the formula of QC squared over XC, and then we can get the value of total reactive power is equal to approximately 600 megabar. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aqilah Aliah, binti Rahim, DE190174. Today I will present for conclusion part. In conclusion, by the end of the project, students will be able to cover a wide range of power quality phenomena and their associated measurements. Next, we'll be able to present application of power quality issues in a meaningful, elaborative, understandable, and concept visualizing manner. Voltage sag, voltage swell, transient, and harmonic are among the power quality issues discussed in this project. All of these issues have distinct characteristics, and the most obvious is the waveform shape. Furthermore, be able to identify the source of the problem that will cause harm, and majority of power quality issues will cause equipment damage. Then we'll be able to prepare a comprehensive report to identify and mitigate power quality issues. The model and electrical schematic were created using MATLAB software. The simulation for task 1 is about mitigating power quality issues caused by overvoltage transients. Then we learn about overvoltage transient, mitigation device, and solution to the problem in this task. The second task is to simulate a harmonic producing load and a mitigating filter. In this task, learn about harmonics and loads that cause harmony in power system. Finally, by completing the project, we'll help to gain more knowledge regarding the various power quality disturbance in a practical environment. That's all from me. Thank you.